In this video, we are going to see an example of flux form of Green's theorem. Here this question is asking, determine the flux of the vector field f is equal to negative x, negative y across x square plus y square is equal to 16. From this one you can see this is a circle and the direction we are going to assume is counterclockwise. Okay, now let's go ahead and draw the diagram. Okay, let's say this is our x-axis. Oh, this is y-axis, this is x-axis and y. Okay, then we are going to have circle with radius 4 because we have x square plus y square is equal to 16. So the circle is going to be with radius 4. Okay, so here we're going to have 4, 4, negative 4, negative 4, and we are going to take counterclockwise orientation. Okay, and this is the equation to calculate the flux of the vector field. Okay, this is the equation. All we have to do is, if you remember divergent equation, that is it. You have to do the double integral for the divergent equation. That is partial derivative of f with respect to x plus partial derivative of g with respect to y, and then we integrate that one. Okay, now let's go ahead and write our double integral. Okay, in our case, the first function, this is our f and this is our g, and we are going to take the f with respect to x, and if you do that, this is going to be just negative 1 because we only have x, so this is going to be just negative 1, and then here we have negative y, this is our g, and if you take the partial derivative of this one with respect to y, this is also going to be negative 1. Okay, right, so we are going to integrate this one. Now since we are dealing with circle pattern, when you have circle pattern, you can always do the polar coordinate. You can always convert this one into polar coordinate. That's what we are going to do because in that way it's easier. And if I convert this one into polar coordinate, this is negative 1 plus negative 1, that's going to be negative 2. And then this is going to turn into r dr d theta. And first we are going to integrate this one with respect to r. And the limits of integration for r is going to be the radius, that's going to be 0 to 4. Okay, 0 to 4 is going to be the limits of integration because radius cannot be negative, we only take 0 to 4. And this is a full circle, so this is going from the theta, limits of integration for the theta is going to be 0 to 2 pi. Now we can go ahead and do the integration, and if you do the integration for this one with respect to r, this is going to become negative 2r square divided by 2, so this is going to be just negative r square. Okay, so this is going to be just negative r square, and that's going from 0 to 4, and the outer limits of integration remains, that's going to be 0, outer integration remains, that's 0 to 2 phi d theta, and if you plug 4 for this one, this is going to be negative 4 square, 4 square is 16, then negative, so negative 16, and then 0 to 2 phi and d theta, and if we integrate this one with respect to theta, this is going to be negative 16 theta going from 0 to 2 phi. Finally we will get negative 16 times 2 phi minus 0, because if you substitute 0 for this theta, that's going to be just 0. So this, the final answer is going to be negative 32 phi, and that's how we determine the flux of a vector field. I hope this helps. Thanks for watching.